Why do we need to use short pulses and indirect methods for studying the molecules? The reason is they are moving too fast in order to be investigated by direct observations. If we compare the characteristic time of the molecular movement with the duration of events that we consider fast, like for example a blink of an eye or a flutter of mosquito wings, we can see that the molecules are moving much faster than everything we could observe in real life. So we need some indirect technique to use in order to get the information about the molecular movement. As indirect method, we can use the sequence of the short pulses, for example, given by the stroboscope. Stroboscope have been proved to be very efficient tool in order to freeze the motion. For example, this picture was acquired while using the stroboscope. An idea is to have a simple model of a molecule which will be rotating fast by the motor, and the flash lamp which will be source of the short pulses. Here you can see the realization of the experiment. You can see the motor which is turning the simple model of a molecule, flash lamp with the generator of pulses for the flash lamp and generator of voltage for the DC motor. And you can see also the box for the security reasons. As you can see, the model is turning too fast to understand from which it consists of and how many balls are there. But if we will turn on the flash lamp and synchronize the frequency of the flash lamp with the frequency of a motor, we can see that our model is consisted of four balls. And we can see that the period between pulses of the flash lamp is 16.6 milliseconds. Now we can use the simple math in order to calculate the frequency of rotating of our model of a molecule. But we need to be very careful because we have used the indirect method in order to determine this information. And we really need to ask a question if our conclusion about the structure of a model and the frequency was correct or not. Unfortunately, we cannot always believe what we see when we use indirect methods. For example, here we clearly see four balls, but if I will change the frequency of the flash lamp, now we see 6 balls. So what is the real structure of this model? In order to understand it, we should decrease the frequency of the flash lamp in order to see the simplest form, the most basic one, which is 2 balls in our case. And we can see that the period between flashes of lamp is 32 milliseconds. So that's why it's very important to correctly interpret all the data which we get from the indirect measurements. Now, with the new understanding of the structure of the model, we can correct our conclusion, and so now we know that it consists of only 2 balls, and we again can calculate the frequency of the rotating. So it's really important to know, to have some theoretical model of the structure before doing the experiment in order not to make the wrong conclusion. And we have seen that using the short pulses of light we can determine the structure of the fast moving object and determine the frequency of it's rotating. In reality, researchers use quite complicated devices in order to have short enough pulses of light. For example, this femtosecond laser has a duration of a pulse like 1/100000th of 1/1,000,000th of a second. Also, it's not possible to see the molecule, but we can still use the fluorescence process, the process of absorbing a light with one color and re-emitting the light with another color. So now you know why the researchers use such complicated system in order to have the short enough pulses, and which indirect method we can use in order to study the structure of a molecule.